Hello, I'm Isaac Dimkoff, and I'm back here with another speech on something nerdy. So, one of my favorite shows is Futurama, and it's basically about a guy who goes to the future and meets a few aliens, regular humans, etc., 1,000 years into the future. But that's not really important right now. What I want to talk about today is something called the Futurama Theorem, which as of now, is the only mathematical theorem created for the purpose of TV, which is just incredible. So this is the fellow who came up with the theorem, Ken Keeler, and hey, look, he's got a doctorate, but he's writing for a cartoon TV show. That's weird. Do what you love. Alright, so for the cast involved in the actual theorem itself are all these characters. We have Amy in the upper left here, got Bender next to her. This is Emperor Nikolai. This is a wash bucket that's also a robot, because why not? Zoidberg down here, Leela in the middle, Hermes on the side here. And then we have these two fellows over here. They'll come into play later. Got Fry over here, and the professor down here. He likes science. So, the backbone of the theorem is the following, I want to call it potential situation. The following situation is sort of the backbone of the episode and the theorem itself. So Amy and the professor have created this mind-swapping machine, which allows any two people, robot or human or alien and otherwise, etc., they can swap their minds into each other's bodies. So, for instance, Amy and the professor end up trying it out, taking it for a spin, and swapping the professor's mind into Amy's body, and vice versa. But there's a problem. As they find out later, or rather, forgot about and then remember, there is some sort of mind immune response, which is basically science for once two bodies have swapped, they can never swap again. However, there's no limitation on the minds. So maybe, through some finagling, there's a way to get everyone into their correct bodies again. So, in the episode, everyone takes the mind-swapping machine for a spin. So, everyone gets all crazy, and everyone takes out various different bodies for a spin. And so the problem is, how do we get everyone back to their original bodies again? So these are the final positions. I have marked each body with a star. So, for instance, Amy ends up being in Hermes' body, the professor ends up being in Bender's body, and so on and so forth. And there's 9 different people that need to go back into their original bodies. So, in the future, the Harlem Globetrotters are from space, and they're good at math. Don't ask. It's a whole thing. I can explain later. Anyway, so Sweet Clyde and Bubblegum Tate come in to help everyone sort out this issue. And they write this theorem on the blackboard behind them. And I'll be honest, I still can't really understand or explain the mathematics behind it. But the gist of the theorem itself is that no matter how many people have switched, however many times, they can all be put back together into their corresponding bodies with the help of 2 additional bodies, as long as those 2 bodies have not had switches themselves. And that's the whole basis of the theorem. It's a whole thing. So let's organize everyone together. So a strategy of solving this, I found, is that you can set up a sort of cycle. So let's start with a simpler one. In the upper right-hand corner, Zoidberg and Fry have swapped bodies, and that's it. They only did one swap each, and just with each other. So obviously, they just need to find a way to indirectly swap, and then they're done. Everyone else, however, needs a little more help. So the way this is organized is I have each mind going into the body, or pointing towards the body it needs to end up in. So for instance, the professor ended up in Bender's body, so he needs to go back to his own body, but currently Leela is there, and she needs to go back to her body, and Hermes is already there, so he needs to go back to his, and so on and so forth, until eventually we get back to Bender needing to go back to his body. And so it's easy. The suggested method is to set up a cycle like this. So let's start with the easy part. So first of all, we use Sweet Clyde, that's this fellow's name, and we swap Zoidberg's mind into his body, and Sweet Clyde's brain into Fry's body. So we have one swap there, and then we swap Bubblegum Tate with Fry's brain, and we put Bubblegum Tate's mind into Zoidberg's body. So we have 2 swaps here. Now, remember, we are allowed to swap, only the bodies are not allowed to swap twice in a row. Only the bodies are not allowed to swap twice at all. But the minds can go through any number of bodies, essentially. So, now that we have them in the 2 outsiders' bodies, we can just kind of put them there, and they're all squared away, they're all done. However, they're in the wrong bodies on the right here. But don't worry, we can fix that. See? Yeah, all fixed, but these guys need help still. However, we're not done, because we still have a whole cycle, so let's fix this after that, just to be safe. So yeah, now we've got all the other people that still need help. And if you look on the right here, I've changed the colors of their stars. This will be important later. So Sweet Clyde's body has a red star, and Bubblegum Tate's has a blue star. And this will be important later because remember, we can't swap a set of bodies twice. So as we go along, I will be changing the stars here to mark which body they've already swapped with, and to remember that we cannot swap those 2 again. So let's start with the first chunk here. I've got a segment of that cycle I was talking about earlier. First, let's make a swap here, and as you can see, I changed the color of the star accordingly. And we will actually come back to this. This is the end of the cycle, based on the arbitrary starting point I chose. And let's keep moving along here. So boom, already got our first fix. And second fix there. Now, we haven't used this fellow yet. We'll get to that, don't you worry. Alright, next part of the segment, I have the final fix up in the corner here. Boom, Hermes is fixed. Amy is fixed. But wait a minute. We have to remember, these 2 can never swap. And if we keep going in the way we're going, then eventually we might get stuck. Because remember, Bender needs to end up in his own body. But if we aren't careful, and we keep on going, we're going to get Nikolai in this body over here, and then we make the swap there. But wait, we can't swap Bender back into his body using this body. And that's sort of where the second body comes in, but there's still some extra issues there, so let's be careful how we do this. So we've got our last set of swaps to do here. So if you recall, we made a swap at the very beginning with these two bodies, and that means these two bodies cannot directly switch with each other. But we'll get to that when we get to that. So let's go ahead and swap with Wash Bucket. There we go. Wash Bucket's all fixed. And now so is Emperor Nikolai. Now, here's that part I was just talking about. So these bodies can no longer swap with each other. However, these two can. And if you recall from our exchange with Zoidberg and Fry at the beginning, we swapped these two with them, and these two ended up being in each other's bodies. So that's why they were transposed. But now Bubblegum Tate is back all together, and now we have one final swap, and these two bodies haven't done one yet, so there we go. All fixed. And now everyone's back in their correct bodies. Thanks to this machine that sort of started it in the first place, and the Harlem Globetrotters. And as long as nobody uses this machine to do that again, they will never have to do math. That's how that works, right? Anyway, I hope you all enjoyed, and check out Futurama. It's a pretty good show. Thanks for watching.